example I want to look at with the addition method is not going to be as complicated as that one we were just looking at. I do want to start off with one that's much simpler, much more straightforward. Then we'll kind of get into the steps that goes about it. Now, one thing that we got to be careful with here. So I want to start off talking about a step that might not seem altogether intuitive, but it's completely legal, and we'll see how it helps us and why it's legal. Now, what I want to do here is I want to go ahead and add the left side of equation 1 to the left side of equation 2, and I want to add the right side of equation 1 and the right side of equation 2 together. So before I show that work, I do want to point out that this is perfectly mathematically legal. This is something you probably haven't done before. There's not really been a need for it. But I want to point it out using a very simple demonstration. So, equations were probably first introduced to you as balance scales. So if you think about a balance scale where we've got kind of a basket on each side, and in order for them to be balanced, they have to have the same amount of weight in them. So I'm not a good artist by any stretch of the imagination. This is my version of a balance scale. We got a little fulcrum there in the middle, and we have a bar, kind of like a teeter-totter, that's going to keep them balanced. And so suppose I tell you that I have a square on one side and two triangles on the other. And I tell you, hey, they're balanced. We're good. And I have a whole separate balance scale over here, and I have two circles over here, and let's go ahead and say one diamond over here. And I tell you they're balanced too. So if these are balanced, then wouldn't it be true that if I have a square and my two triangles, I'm still balanced? And if I put my two circles and my diamond, it should still be balanced. So all I did is I took everything that's on the left of either one and put it down there at the bottom, took everything that's on the right of either one and put it together, and if both of the original ones were balanced, the bottom one's balanced too. So if you can visualize that, then we can go back to our equation and say it's okay to add the left sides together and the right sides together, and that's going to get me a new equation. And that's exactly what we're going to do for what's called the addition method. In the addition method, we're going to be adding things together in order to eliminate a variable. So now take a step back again. And if you remember when I was talking about the various algebraic methods, I said both of them that we're going to talk about have the same overall goal. And that overall goal is to start with two equations, two unknowns, and do something until we're down to one equation, one unknown. With the addition method, if I add together x plus x is 2x, and y plus negative y is 0. 7 plus 5 is 12. So that's how we can kind of get rid of a variable or get this down to one equation, one unknown, is because of the fact that y plus negative y was 0. So this first example I kind of handpicked. I made it what I like to call the perfect scenario. Everything worked out nice. We add together. The y is gone. Now it's easy. Divide both sides by 2. My x value is 6. Now that I know my x value is 6, I can plug this back into either one of the original equations. Doesn't matter. I get 6 plus y equals 7, so y must be 1. And I've got myself an answer. 6, 1. It's an easy answer to check. First equation, 6 plus 1 is 7. Second equation, 6 minus 1 is 5. We're all good. That is, in fact, the correct answer of 6, 1. So, something to think about as I kind of wrap up this example here is you need to look at this example and say, why was this one so easy? What made it work that when I added them together, the y's went away? Well, the y's were opposites. That's what we want. So we're going to, in the next example, talk about the steps that we're going to go through for taking care of these types of problems, for solving using the addition method. But we're going to keep in mind, no matter what we do, no matter what steps you throw on something, your basic goal is to have opposites that you're adding together. That way they go away.